welcome back to the Tin Barn. I'm Pragmatic Lee, and we've got a little project today for some friends of mine, Chad and Christine. About a little over 3 years ago, I guess it's been now, when I got my first little Harbor Freight 7X lathe, Chad contacted me about making some tube ends for Christine's quiver. Christine is a pro archer, and she had just had a custom angel quiver made for a custom-made quiver, and when she put the arrow tubes in there, didn't really like the way the ends of them looked. They were carbon fiber, sawed off, and if you've ever dealt with carbon fiber, you know those ends after a period of time will start to ravel a little bit. So they wanted some sleeves to go on the end of them to dress them up. Here's a before picture of what her quiver looked like when she put the arrow tubes in it and started using it. So they contacted me and asked me if I could make them some little sleeves to go in the ends of those tubes, and here's what we come up with. Well, Chad just contacted me earlier this week, I guess it was. They've recently got on my boat. Got on a nice boat, and here's the problem that Chad had with the boat. If you see this hose just laying there, you don't really need anything laying on the floor of a boat, especially if you're out in a little bit of choppy water. So he wanted some way to store that hose back, get it out of the way. I think his plan is to use a retractable hose reel that will be hid either up under a seat or back into a compartment somewhere. But he needed a flange to go around where that hose would feed through. I'm sure he checked around on the market and looked around for something that would work in there. Evidently he didn't find anything, so he asked me if I can make him one. And always glad to help out friends on small projects like this. I don't take on any big jobs. But he wants it made out of stainless steel, and I was able to find some stainless steel drops. These are 3/16 thick by 2 3/4 diameter. What he needs is 2 1/4 diameter with 1 1/4 hole in the middle for the hose to feed through. This flange will be mounted on the boat, the hose reel back behind it, and the hose will feed through that. Of course, he wants it nice, bright, and shiny to go on the boat, as you'd expect from stainless steel, and this is just a mill finish on there. As a matter of fact, it looks a little porous right on the edge there from the mill slag. So I took one of the pieces yesterday and some different grades of sandpaper, and was able to get a semi-mirror finish on there. It's a whole lot better than what the original was. We're going to polish this up some more after we get it made, but the first thing we're going to do is turn it to diameter. You've seen me in previous videos use this double-sided duct tape. Put a piece of duct tape on the back, push that up against the chuck jaws with the live center held on this side, and turn it that way, just held by friction. Won't be able to do that with this piece, because my chuck jaws are actually, even pulled all the way in, are larger than the 2 1/4 outside diameter. So I'm going to have to do a little bit different this time. The first thing I need to do is locate the center on this side. So let me turn the camera down and we'll get that done. All right, using a Sharpie here, I'll just mark the center area a little bit. Taking my center square, using my Randy Richards scribe, and we'll get 2 or 3 marks with the center square here, just to be sure everything is lining up on center. All right, what that gave me was a little center point in there. Now I'll take my punch. This, of course, is going to be drilled out, but I need something close to center. All right, now let's carry this over to the lathe and we'll get this set up. All right, the way I'm going to hold our piece in the lathe is with some super glue. I've seen other guys do that. I've never done it, but I'm sure going to give it a try. Let me grab a towel right quick. Well, got a little acetone here. This is just simply a little arbor that I've going to use in the chuck. Put a little grid pattern on there to help release the super glue after we get done, if this works. So got that cleaned up, got that loaded. Clean up the back side of our workpiece. Now I'll give that just a moment to dry good. Of course, acetone is the enemy of super glue. That's what we'll use to remove it. So what I'm going to do is going to try to get some super glue on the back of this. Use the point of our live center where we punched center right here and friction hold that in place. Let me be sure I've got the tailstock where it needs to be. Alright, that should be good on the tailstock, so I can lock that down there. Gonna have to be fairly quick on that because, of course, this is running material, Alright, I'm on center there. I'm up against my piece. I'll tighten that down good and tight. And I'm going to give this a minute or two to set and clean up my mess here. I should have put a towel down on the cross slide, but clean that up right quick and be right back. Okay, I think I got a good bond now. It's not exactly in the center, but we're gonna turn this down. So I'm gonna take very small cuts on this, especially until we get it round. We've got an interrupted cut right now. All right, that was taking a 40 thousandths cut, 20 thousandths off of each side. Might have been pushing it just a little bit for this glue bond. Now I'm gonna go down to 30 thousandths, that's 15 on each side. I'm gonna get a measurement on this, set up a coordinate on the DRO. Chad's instructions was this couldn't be no more than 2 1/4 inches. So I'll bring you back when we get ready for that, about the last couple cuts. Okay, we're at 2.251, 2.252. So we're going to take just another thousandths off of that, just to clean that up. The super glue has held fine. Now on this back edge, it has rolled a pretty wicked chip back there, burr on the back. We want to leave that surface about as flat as we can, but definitely need to take that that chip off that back side. So I'm gonna, let's see, I don't have a left-hand tool set up in there. I'll go with just this 30 degree or 60 degree and just take that off until we even with the bottom. Now on the face out here, we do want a pretty good chamfer on that. All right, that looks good. Don't see any chatter on there. Let me double check one more time. Be sure we're at 2.125 inches or no more than 2.25 inches. Might be still a couple thousandths over. I've got a burr right there. That rolled from that back side. Two and a half tenths under 2.5. So I think we're fine on there. Now we want to see if we can get this super glue loose, see if we can get our piece loose from the super glue. I'm going to put me a drip cloth down here first, and this is a pig syringe with some acetone in it. Might should have cut them grooves in the face a little bit deeper. We've got pretty good glue. You can see where the acetone has took that loose there. So I'm gonna get this cleaned up, get this out of the lathe, then we'll get set up to bore this for our center hole. Okay, I've got the rest of the glue off of it, laid it down on the belt sander and got any of that rolled over edge that was left on there, got that taken care of. So now we're going to mount this in the chuck, and this is going to be an 1.25 inch hole in there. This is a large bore lathe. That's 1.75 inches there. So I can put this right up against the chuck body itself. I'm not going to put a death grip on that because we're just going to drill it nice and slow and easy to begin with. Be sure that's up against the chuck good. Now we're going to step drill this. I've got a 1-inch drill that will get that close, but again, I don't want to put that much pressure on there and take a chance of turning that, twisting that. So we're going to go with just step up to 5/8 and then use a boring bar. Okay, now we're done with the drilling. I'll put my 1/2 inch boring bar in there. And I think I should be able to retract it a little bit in the holder. It's sticking kind of far out now. Of course, I don't want to get into chuck jaws by any means. First thing I want to do is set a stop, a hard stop for the carriage, so that I don't accidentally run into the chuck. Okay, I'm going to measure that, set a coordinate on my DRO, and I'll bring you back when we get a little closer. All right, we got about one more cut to make, so a cut and then a cleanup. Of course, with a boring bar, I'm gonna make a couple spring passes without changing the cross slide. We're looking 1 1/4 there, at least 1 1/4, and we've got 1.230, so we've got another 20 thousandths to go. This stringy stainless steel, of course, has rolled that big burr up on the back side again. That's right, dead on 1 1/4. I'm going to take one more pass. He said at least 1.25, so if we give it just a little extra, about 10 thousandths extra. And again, we got that ugly burr on the inside in there. Plus we need a chamfer. This is where the hose is going to go and come through there. So we definitely don't want any, we don't want any burrs left. I'm going to use this, I think I'm going to use this internal threading tool. I need to advance it out just a little bit. But what I'll be able to do is take this edge and get the inside, and then this edge and get the outside. I'm going to need to stick it out a little bit further. Don't like to do, but don't want to crash into the chuck either. Now, I can't actually see where the tool is from this side. I'm just going to try to keep an eye on the other side as it's turning. Y'all might have a better view on that side than I do. Oh yeah, that's got a good edge. Good chamfer on the inside. Now the chamfer I'm going to put on the outside, I'm going to see if I can, I'm not sure how much I can, without getting chatter with this tool, I'm going to see just how close I come to matching it to the one we put on the outside. That's just going to be too much chatter to try to put that big a chamfer on there. But that's got it where the hose will be clear now. All right, I think we're ready to carry this over to the mill. Get it set up on there to drill our three-hole bolt pattern. All right, I've got my pallet over here in the mill vise. Got a sacrificial piece in between here. Got our flange mounted with clamps with some little cushions in between, just little pieces of aluminum. Use the dial test indicator to locate center. I've got the DRO set on center. So now we're going to use the DRO to set up a bolt hole pattern. The inside was 1.25, outside was 2.25, so that's a 1 inch difference, half on each side, so half plus the 1.25 means our bolt hole pattern is at 1.75. So over here on the DRO, we'll hit the bolt hole pattern, and we are using the XY axis. We're starting on center, and we're zeroed. The diameter of our hole is going to be 1.750. All right. Number of holes is going to be 3. Starting angle is 0. Ending angle is 240. That's just basically 360 divided by the 3 holes is 120. 120 from 360 is 240. So our first hole says move the X to 0.875, or it says it's telling us to move the DRO to 0, which is 0.875 over. The way I'm going to do this, I'm going to drill, or I'm going to start drilling all 3 of them. Then we'll come back and drill through. Then we'll come back and countersink. Now we want our second hole. So we move both axes to 0. Third hole. Okay, for the sake of full disclosure, I made a little mistake here. I didn't check distance on this piece before I clamped everything down and found center. I cannot advance my y-axis far enough. I'm about 100 thousandths short to come up to this hole. So what I'm going to have to do is move this piece back on the pallet, relocate center, which won't be hard at all. What's going to be hard though is picking up these 2 holes again. So I'm going to do that. Might take a little break. Then I'm going to do that and I'll bring you back. Okay, always check for clearance before you start drilling a hole or doing whatever. Normally my work is located on the mill right over the vise jaws, and I know approximately how much clearance I've got in every direction for that. Didn't think about it, I'm offset over here. But I've got it back, and I'm pretty sure we've picked up. We'll go back through the bolt hole pattern for each of these to be sure we're where we want to be. And I'm back at 0 on the DRO. And understand this 4th digit on the DRO is tenths of a thousandths. If I'm moving toward the 3rd decimal place thousandths, it's plenty fine for what the work we're doing on this. So we'll go to the bolt hole pattern. Again, we're on the XY axis. We're starting from center. 1.75 is our diameter, 3 holes. Starting angle 0, ending angle 240. First hole, 875. And that goes right in the existing hole that we drilled earlier. Second hole. And that goes in. We're lined up there. So we'll go to our third hole. And this is where we ran out of space before. Okay, no harm, no foul. But I wish Bozo would go back to West Coast or somewhere and stay out of my tin barn. So now we're gonna drill. And I'm gonna drill well into the sacrificial plate. But I don't want to drill into my pallets, so we've got about, if I drill 0.6 inches, I should be fine. So I'll set the Z-axis DRO at 0.6. Set it at 0 and drill to 0.6. All right, this stainless is some hard stuff. I think I may have to get a different bit. Sometimes a chip will get in between your workpiece and your tool, and it'll kind of skate on that, and I think that's what was happening there. Now we'll go back through our holes, back to 2. All right, now we're ready to countersink our holes. Okay, I sacrificed one of my 832 stainless screws here, just so I've got a something to measure this countersink with. I just realized these are not the stainless ones. The stainless I have are screws. These are little 832 bolts. All right, that looks good. You can tell it's not stainless because a magnet will pull it right out of there. All right, so I'm going to set the Z-axis DRO at 0 right there. Now let's go to hole 2. Now finally to hole 3. Okay, I think the machining is done on this now. I'm going to swing the camera around and we're going to polish this just a little more around there to get a little more of a mirror finish on that. To put some final polish on this, I've just got my palm sander just clamped lightly in this little bench vise here, or machinist vise. And I've got some 1000 grit paper on it now. That's starting to give a good polish on there. I'll probably do this for about 30 minutes just to get a good bright mirror finish on there. And then I think we'll call this project finished. I hope you've enjoyed it. Take care and we'll see you on the next video.